Good evening to all. So let us start our today's session on the following, that so these are the topics which we are going to discuss for today. Since earlier we have discussed about 4 methods, let me say e power ax, sin or cos, x power n, e power ax into some function. So these are the methods which we have discussed earlier. So the other method or other procedure is when the RHS is of the form x power n into some function, say sine or cos or exponential function or any other. So in such cases, how to solve the problem? That is one. And secondly, going for the problems on variation of parameters, which contains 2 varieties. One, the LHS coefficients are constant, and the second, LHS coefficients are non-constant. And finally, Cauchy-Euler equations. So I am going to focus on the problems on the above modules. Okay. So can I start the formula then? I hope that all of you have done the daily test. I hope so. At least you have tried some of them. And I have given the solutions also there to have a cross check whether you have achieved the right answer or not, comprising all the previous models what we have discussed so far. May I know how many of you have tried? Or you just put it as a pending so that tomorrow is a holiday, so we are going to finish by Monday? Say, so any other person have done it or tried half of the part for the 20 problems posed there? Okay, fine. So I think majority of you have concentrating on the prelims exams. I hope so. So all the best. So I give the formula first, how to solve it. So let me take the problem first, then we will have an idea. So please note down the problem. D square plus 1 of y equal to x square sine 2x. So usually we apply this procedure whenever x contains more than power 1 and the other function in the product is sine or cos. So for those things, we are going to make use of this procedure. And if you calculate YC, it is C1 cos x plus C2 sin x. Accepted? Fine. Now to find YP, 1 by d square plus 1 into x square sine 2x. So as we know, e power I theta is equal to cos theta plus I sin theta. Here cos function we call it as the real part and sin function we call it as imaginary part. So this can be written as 1 by d square plus 1 into x square e power 2ix. Before that we take imaginary part. Fine. So the technique here is we will convert sine 2x in terms of the exponential function so that we are going to make use of the formula e power ax into something. That is why whenever cos function is there, we take real part e power 2ix. If sine 2x is there, we take imaginary part e power 2ix. Okay? Are you getting the logic? Yes or no? Now, applying the same criteria, imaginary part e power 2ix comes to the front and d should be replaced with the power 2i. So, d plus 2i whole square plus 1 of x square. So, imaginary part e power 2ix 1 by. If you simplify the thing, you are going to get it as d square plus 4di minus 3 of x square. So you are going to apply the technique of x power n, which we have discussed earlier, nothing but the denominator should be written in the form of 1 plus or minus something. So to achieve that, imaginary part e power 2ix by minus 3. So 1 minus of d square plus 4di by 3 whole power minus 1 of x square. Is it acceptable? Please take the procedure. Right. Now I am going to expand that and I will write the expression value straight away. So to save the time. So imaginary part e power 2x by minus 3 of 1 plus 4di by 3 plus d square by 3 minus 16d square by 9 of x square. So please take a note of that. If any doubt is there, you can ask. So I have written the result on simplifying the expression in the expansion. Yeah. So the first thing is, whenever sine 2x, sine 3x, those functions are given, we are going to make use of e power ix. So this procedure we apply whenever x power n into something will come. So usually x power n into sin x, x power n into cos x, when such kind of functions are given on the right hand side, we are going to make use of this procedure. What is the technique? Here sin 2x is there. In the value e power I2x, sin 2x is imaginary part. So we replace sin 2x with e power 2ix and previously we indicate imaginary part. So this entire thing will come under the form e power ax into say v, some function. So what is the procedure we deploy here? E power ax should be taken to the front. The differential d should be replaced with d plus the power a. And then on simplifying, you are going to make use of this thing, the expansion, either 1 plus x whole power minus 1 or 1 minus x whole power minus 1, whatever it is. So we simply expand this and apply the function here. Okay. right? Now what happens? Since you are going to calculate the imaginary part, so this value we multiply with cos 2x as well as I sin 2x. Since we are considering imaginary part, we take the terms which contain the coefficient I, because imaginary part stands for I. So on multiplying this expression with cos 2x and also with I sin 2x, we consider the terms which contain I only. So if you write that on simplification, I will say the result will come in this manner. So I am writing the simplified answer there. So these are the terms which contain I, and the remaining terms will be neglected because they are the real part terms. However, see, cos 2x into 8x by 3, if you multiply, I will be there. Say yes or no? X square cos 2x minus 26 by 9 cos 2x. Similarly, I into 8x by 3 cos 2x. Am I correct? So we are taking the terms which contain I. So here you are asking, right, how cos 2x come? See, this is e power 2x. E power 2ix is nothing but cos 2x plus I sin 2x. I have written the value as it is. Because previously we have imaginary part is there and we are considering only the terms containing I only. Accepted now? Fine. Any other queries to anybody in the procedure? So please take a note of that. Sure. Take your own time. Right. So we have IP e power 2ix by minus 3 of terms I have written on applying the expansion. Later, imaginary part, e power 2x is nothing but cos 2x plus I sin 2x by minus 3. The terms on simplifying the expansion. Now, you are multiplying all these terms with cos 2x as well as sin 2x, and imaginary part indicates the values which contain I only. So in the whole expression, you are writing the terms which contain I only. So imaginary part of the whole expression, and it is replaced with the terms which contain I only. Remaining terms are neglected. If the same problem is asked for cos 2x, so we write that RP, real part of, real part of, real part of. The same procedure applied for the problem without any change, right? And at the end, we consider the terms which do not contain I. So let us take the problem that d square plus 3d plus 2 of y equal to x e power x sin x. I think this kind of problem is asked earlier. So please take a note of that. Right. So here yc is given by c1 e power minus x plus c2 e power minus 2x. Now coming to yp, if you observe the right hand side part, it contains three functions: x, e power x, sin x. So whenever three functions are there, we always treat that it is of the form e power x into something. So first we apply the methodology of e power x into something. Later we go with the remaining procedure. So it is e power x into 1 by d plus 1 whole square plus 3 into d plus 1 plus 2 of x into sin x. So if you simplify the part, it is 1 by d square plus 5d plus 6 of x into sin x. You please check that. Now here what happens? We go with the regular procedure what I described here. So e power x, in place of sin x we can write imaginary part because it is x into something given by. So imaginary part e power ix 1 by d plus I whole square plus 5 into d plus I plus 6 of x. So can you simplify and give me the denominator value to me? Please go ahead. So based on your answer, I am going to simplify that. So d square plus 2i plus 5 into d okay, and then 5d plus 5. Now all of you agree with this thing? Fine. If we apply that 1 plus something, if we are going to write, we have to write it as e power x imaginary part e power ix by 5 of, it will come as 1 plus something. So 1 plus and you are going to simplify that. It is 1 minus something so can you apply the value there? So for d square it is 0, differentiation value 1, here differentiation value 1. So it is e power x imaginary part e power ix by 5 of x minus 2i plus 5 and then 5 by 5. Accepted? So 5i. So here we have 5i. Okay, 5i, not 5d. So at the end you are saying, right? Thank you. Accepted now then? So since e power ix is nothing but cos x plus I sin x, so you multiply all the terms and you are going to take imaginary part, that means terms having only I in them. So this is one way of doing the problem. So whenever this kind of thing is there, it takes much time to simplify the denominator expression. Sometimes the I in denominator gives you difficult values to simplify this expansion. So to avoid that, whenever x has power 1, we will make use of another formula now I describe, right? So I think all of you have agreed up to this step. Accepted? What to proceed? Please tell. Yes or no? Yes, we will have other terms also. Since x has power 1, higher terms gets cancelled. Yes or no? So we are not applying the other terms. I have just applied 1 minus x up to that. Power of x. Yes, 5i is there. So your question I didn't get there actually. Here we have 5i, right? I have applied that. The whole thing is taken as some number. So if it is 5i, you are going to divide with that 5i plus 5. Accepted then? Very nice. Just hold on a second then. We are going to change it. It is not 5, it is 5i, or it is 5i plus 5. Is it the correct value you have posted earlier? 5i plus 5? Right. So if you want to simplify, it will come like this. However, you know the thing, 1 minus this thing will come. So now the simplification takes a little bit. Accepted all? So the concept of real part, imaginary part sometimes make you difficult to solve this kind of problems when x has power 1. So for this, we use this formula that 1 by f of d into x into v, say x into cos x or x into sin x. Whenever this kind of thing is there, we are going to make use of the formula that x into 1 by f of d into v minus f dash of d by f of d whole square of v. So please take a note of the formula. So whenever x has power 1, in place of v, we have sine or cos function is there. In such cases only we make use of this formula. For all the remaining things, we always stick on with real part and imaginary part, that model only. Okay? Clear to all? right? Now I am going to erase this. So this is my first step earlier. X into e power x into sin x is given as q. I have written it as e power x into sin x into x. So I applied the formula first. E power x is taken to the front, x sin x is remained. This is the simplification part. So from this onwards, I am going to make use of the formula which I mentioned now. So this is v, this is x, and this is f of d. So applying the formula, e power x into 1 by d square plus 5d plus 6 into sin x minus derivative of the value is 2d plus 5 by d square plus 5d plus 6 whole square of sin x. Please check it. The formula which I have written earlier. So this expression will be simplified with the concept whenever sin or cos is there, how to simplify, the same thing will be given. So d square should be replaced with minus d square. The remaining procedure will be applied here. So here v is only this one, either sin or cos, whatever it is. Usually we have only two choices. Whenever x into v model is there, it must be either x into sin x or x into cos x. No other function will come. Right. So this value is equal to e power x into 1 by minus 1 plus 5d plus 6 of sin x minus 2d plus 5 by minus 1 plus 5d plus 6 whole square of sin x. Okay, please check that. All of you agree? Fine. X by 5 into, here we rationalize. So again, in place of d square, we write minus 1. Here also we write minus 1. And on doing rationalization, you will get the required solution. Okay? Once you know the procedure, there is no need to write the remaining steps. All the thing is how to approach for this kind of problem. Accepted? If any queries, you can ask. So shall I continue here? The next step by writing the final answer on simplification? All of you? Or you want the other steps to add? Okay. So the final YP value on simplification is e power x into x by 10 into sin x minus cos x minus 1 by 25 sin x plus 1 by 10 cos x. This is the final answer on simplification. right? So any other queries for anybody in the approach so far discussed? So can I take the other one then? So here we conclude the discussion of the procedures. Now we are going to make higher order differential equations with variable coefficients. Higher order differential equations with variable coefficients. So please take a note of that. And our discussion is confined for only second order equations. So however we put the heading higher order, our problems are confined to second order only. Okay. Now the differential equation which we consider in this module is of the form d square y by dx square plus some value into dy by dx plus some value into y is equal to right hand side value. So we take that this value is p, this is q, and this value is r. Now what happens? The solution for this thing when p, q, r are functions, not numbers. Whenever p, q, r are in general functions, not numbers, how to solve? For that, for the given equation, you need to find one solution first. Let us take a name that solution is u. Now what happens? It will have the another solution v. So y is equal to u dot v is the final solution. Are you getting the logic? I will explain again. The second order differential equation should be in this form. D square y by dx square plus some coefficient into dy by dx plus some coefficient into y equal to right hand side value. For the given equation, we have to find one solution. I will give the process how to find that solution. Right? I am calling that the solution as name u. So the final solution of the differential equation is y is equal to u into v, where v is another solution which we have to find. So one solution is predetermined. Another solution we are going to find by means of a process. Multiplying these two will give the final solution. That is the overall idea. Okay? All of you clear with this? Right. To find the first solution u, we will check some of the conditions. So I will write the conditions. Please take a note of that. Since you know what are the coefficients there, you evaluate the value 1 plus p plus q. If the value is 0, e power x is a solution. If 1 minus p plus q is 0, e power minus x is the solution. Right? And if p plus qx equal to 0, x is a solution. And 2 plus 2px plus qx square is 0, x square is a solution. So please note down these conditions. So after considering the second order differential equation, we write the coefficients, what is P, what is Q, what is R. Later, we check one of these conditions, one after the other. You can check in any manner. P plus Qx, 2 plus 2px plus qx square, 1 plus p plus q, 1 minus p plus q, m square plus m into p plus q, m into m minus 1 plus p mx plus qx square is 0. So which condition gets satisfied? That corresponding function is a solution of the differential equation. Okay? So please note down these conditions, then I will go with the illustration of a problem. Because this method is somewhat typical to understand. By doing the problem only, we are going to understand it. Right. Have you noted these conditions? Please note down. If p plus qx is 0, x is a solution. Please understand, for every problem, we write the complementary function yc, right? Generally c1 e power x plus c2 e power minus x, etc. So, in the complementary function, generally what happens? Now, what are the roots of it? 2 and 3. Then, if you calculate yc, c1 e power 2x plus c2 e power 3x. So, e power 2x is a function and e power 3x is another function. Accepted? Okay. Minus 2x minus 3x. Accepted all? Here, the coefficients are purely numbers. If functions are there, then how to find those roots? Can you imagine? If roots are there, then how to find the function in the complementary function? Here, e power minus 2 is a solution means in the given differential equation, in place of y, if you substitute e power minus 2x, the equation gets satisfied. Isn't it? dy by dx, d square by dx square, if you substitute, it gets satisfied. If you take variable coefficients, the coefficients are functions, then which function will satisfy the given differential equation? There is a dilemma. For that, these are the checklist or checking conditions. 1, 2, 3, 4, 5, 6. 6 conditions are there. Accepted? Are you getting the idea? Shall I continue further? Okay. So please take the problem. So please take a note of it. X into d square by dx square minus of 2x minus 1 into dy by dx plus x minus 1 into y equal to e power x. After noting, please inform. Okay. So first thing is we have to check whether the given equation is in the required form or not. Since d square by dx square has a coefficient, so it must be eliminated first. So d square y by dx square minus 2x minus 1 by x into dy by dx plus x minus 1 by x is equal to e power x by x. So, if you compare the given equation with the form I have mentioned earlier, so P is equal to minus 2x minus 1 by x and Q is equal to x minus 1 by x and R is equal to e power x by x. Accepted? So we have the checking list: P plus Qx, 2 plus 2px plus Qx square, 1 plus P plus Q, 1 minus P plus Q, and so on. So among those conditions, which condition will be get satisfied, we have to check. That will be done as a rough work. So here, if we calculate 1 plus P plus Q, its value is 1 minus 2x minus 1 by x plus x minus 1 by x. If you find LCM, it will become 0. Please check that. All of you accept? Right. So, e power x is a solution. Therefore, e power x is a solution in the complementary function. Therefore, y is equal to uv is the general solution where v is another solution we have to found. This is the ideology. Please take a note of that. So e power x is a solution in the complementary function. Y is equal to uv is the final solution where v is another solution which we have to find. Accepted? Shall I proceed further then? Right. Now, you need to note down this formula. After finding one solution, this is the formula which we use to evaluate V. Please note down this formula. Like d square V by dx square. Now here, we take that dv by dx is equal to some function, say z. 。 . 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . and we are going to substitute the corresponding values in this formula or in this equation. So what happens? It is dz by dx plus p means minus 2x minus 1 by x plus 2 by e power x into e power x of z is equal to e power x by x into e power x. Please check whether I have substituted all the values correct or not in the formula. This is the actual formula to be remembered, in which I am taking dv by dx as z. So d square v by dx square will be taken as dz by dx. Clear? The solution which I have found earlier, that is e power x, I am taking it as u. If you have any queries, you please ask. If everyone is clear with the approach, then I move further. Two by u into du by dx. Differentiation of the solution which you found. So e power x differentiation is nothing but e power x. Accepted? Right. I will wait. If everyone is clear with the approach, then I move further. Any doubts till so far, you can ask. Shall I proceed then? Right. Now here it will come as dz by dx plus this gets cancelled and this will be 1 by x of z is equal to 1 by x. Now, after applying this formula, usually the result will be either variable separable form or linear equation form. That is by default always. So, after finding u, after substituting respective values in this formula and simplifying, the resultant should be either variable separable or linear equation. Since it is linear, we go with the regular approach. So integrating factor equals to e power integral 1 by x dx. So e power log x is equal to x, and z into integrating factor equal to integral 1 by x into integrating factor dx plus c. So z into integrating factor is x is equal to integral 1 by x into x dx plus c. Accepted all? Now, our concept is to find v. What should be v? From this equation, we have z is equal to, dividing with x on both sides, 1 plus c by x. So z is nothing but dv by dx. So is equal to 1 plus c by x. On integration, you can take, you have v is equal to integration x plus c log x plus integration constant c2. Is it clear now how we have determined the other solution v? Please take a note of that. So the final solution is y is equal to uv. In this, u is nothing but e power x, v is nothing but the solution which we have determined now. So substituting these two values, we have found the total general solution of the given differential equation. Please take a note of that. Will they give conditions to get C and C2? Actually, that thing won't be given in the problem. However, instead of finding u, if they have provided solution u, then all the thing remain with you is to find v and find C1 and C2 at the end by using the given conditions. But on the whole, it is a typical problem. It takes much time in doing. Accepted? Right. So I want to take just one more problem on this model so that you can understand how important this model in evaluating the variable coefficients under second order differential equations. You can have the idea. So after noting this, you please inform, then I move further. Is it okay? All of you have noted? Fine. So the problem is d square y by dx square minus cot x into dy by dx minus of 1 minus cot x of y is equal to e power x into sin x. So please note down the problem and give me which function will be the solution of it. So the maximum complexity you can expect under this category is this kind of problem. The coefficients involving sine and cos functions, etc. Yeah. So here p is equal to minus cot x, q is equal to minus 1 plus cot x, and r is equal to e power x into sin x. So you have 1 plus p plus q equal to 0. So e power x is a solution in the complementary function. Now y is equal to uv is the general solution, where v we have to found. In exam point of view also, you have to write or you have to mention the same writing. Let us take uv is equal to e power x, y is equal to uv is the general solution, where v is another solution which is to be determined. We have to mention that. Otherwise, which methodology we are applying, the examiner won't know. I mean, the evaluator. So straight away apply the formula d square v by dx square plus p plus 2 by u into du by dx of dv by dx is equal to r by u. And let us take that dv by dx is equal to z for convenience. Gives that dz by dx plus p means minus cot x plus 2 by e power x into e power x of z is equal to sin x. All of you accepted? Since we are representing the answer in a formal way on paper, so it is just like a courtesy thing to write the methodology which we are applying there. You can write straight away the answer. Without writing 10 steps, 1, 2, 3, answer will be completed. But if you have written in detail, by using proper uses of time, it will be more applicable or appeal. Fine. So shall I continue further? I think it is a linear differential equation. Say, if anyone has any doubts at this point, you can ask again. In the procedural approach. Shall I proceed then? So you have integrating factor is equal to e power integral 2 minus cot x dx. So e power 2x into e power minus log sin x is equal to e power 2x by sin x, which is the integrating factor, and then z into e power 2x by sin x is equal to integral sin x into e power 2x by sin x dx plus c. Is e power 2x by 2 plus c, which gives that z into, z is equal to sin x by 2 accepted. So please check with that part. And z is nothing but dv by dx. So this implies dv by dx is equal to 1 by 2 sin x plus c into e power minus 2x into sin x. So any queries you have up to this step? So making it variable separable, straight away doing integration, we will have the value of v. So I will write the value of v straight away. It will be minus 1 by 2 cos x plus c by 5 e power minus 2x into minus 2 sin x minus cos x plus c2. Please check with that. And general solution is given by y is equal to uv. If anyone has any doubts, you can ask. So I think the two problems which we have discussed now, I think everyone is clear with the approach in solving the problem, how to solve. The only thing left is doing more number of problems as a practice. Accepted? Or still you have any doubts with regard to approach? Okay. The only thing is, If the 6 formulae are not useful, obviously he will mention one function which is u in the problem itself. For example, I just want to give the thing that, just hold on a second, I will write the problem. There is no need to solve it, but I will write the problem for you. Sin square x into d square y by dx square is equal to 2y. So the problem is given by sin square x into d square y by dx square is equal to 2y, where y is equal to cot x is a solution. Now you can observe that the earlier 6 formulae are not useful. The total 6 formulae will give the functions of the type either exponential or x power something, isn't it? But here, for this problem, cot x is a solution, which cannot be determined with the 6 formulae which we have noted earlier. So, for such kind of typical problems, he will give the solution automatically in the problem itself. If you want to extend the question, the only thing is you have to determine the constants C1 and C2 by using the conditions given in the problem. The maximum difficulty for such kind of questions. Okay? If the approach is clear, then I go with the method variation of parameters. Shall I continue? Okay. So I will take the part up to ODE, in which Laplace transforms part will be covered by Venkana sir in the due course. So by finishing with higher order differential equations, I will resume later. Fine. So here we go with variation of parameters. Usually, a problem will be asked by using variation of parameters, solve this. It is okay. Otherwise, in majority of the cases also, we can make use of variation of parameters exclusively for second order differential equations. And the advantage of this method is, the methods so far we have discussed are applicable for e power x, sin x, cos x, x power n only. But for tan, secant, cosecant, log x, etc., the procedures which we have learned are not useful. So the advantage of this method is, even the right hand side contains functions like tan, secant, cosecant, we are going to solve them by using this methodology. So I will write the procedure. First thing is, for the given problem, we have to find yc first. So obviously, we are doing only second order differential equations. So it will be C1 into something plus C2 into something. So these two functions, usually we take it as this is u and this is v. And the general solution y is given by yc plus yp. And for yp, we use the following procedure. So yp is given by a into u plus b into v, where a is equal to minus integral vr by uv dash minus vu dash, b is equal to integral ur by uv dash minus vu dash. This is a procedure for variation of parameters, so please take a note of that. So the first thing is, for using second order differential equations, we can apply this method. we have to find the complementary function yc first. The functions which are given in the yc are taken as u and v. Using the complementary functions, we are finding the particular solution yp. How to determine yp? The formula for yp is a into u plus b into v, where a and b are the functions are determined by using these two integrals, where r is nothing but RHS of the given problem. So after noting this, you please inform, we will take a problem which gives good idea. Any doubts for anybody in the procedure? Right. So the problem is solve d square plus a square into y is equal to tan ax. So if you write the auxiliary equation and find yc, we have m square plus a square equal to 0, m equal to plus or minus ai. So yc is equal to c1 cos ax plus c2 sin ax. So you can take the functions in any manner. First one is u, second one is v, or any other manner. So you take that u is equal to cos ax and v is equal to sin ax. If you consider uv dash minus uv dash, it will be a. Please check on that. I think you are doing the problem simultaneously with me. Am I correct? Any doubts for anybody in getting the approach? Fine. So yp is given by the particular solution a into u plus b into v. So for a, we have minus integral v into r by uv dash minus vu dash. So minus integral, v means sin ax, r value is tan ax by a dx. So equals to minus 1 by a integral. So the numerator is sin square ax by denominator cos ax dx. Equals to minus 1 by a integral. So 1 minus cos square ax by cos ax dx. So doing integration, 1 by cos ax is secant ax, integration is log of secant ax plus tan ax by a. And for it is cos ax, integration is sin ax by a. So please check the solution once we have done. The second integral is very easy. Can you find b on your own? I will say that the value of B will come like this. Right. So in YP, A into U plus B into V, you have to substitute the values. If possible, you simplify, and the general solution is written Y is equal to YC plus YP. Okay. So let me take the other problem. Shall I proceed? So solve that d square minus 2d plus 2 of y equal to e power x into tan x by using variation of parameters. So here I will write the roots 1 plus or minus I. So yc is equal to e power x c1 cos x plus c2 sin x. So you please confirm the answer after finding the roots. Now what will be u value here and v value here? So here u is equal to e power x cos x and v is equal to e power x sin x. You please give me the input of uv dash minus vu dash to me. I say that you are going to get it as e power 2x. Please check. Since it is the easiest method in second order differential equations on the whole, it is better for me to take inputs from you. If anybody has a problem at the step, I will write the solution on board. Otherwise, you do it on your own. So in uv dash minus vu dash, we are applying product rule in finding the derivative of the function. Accepted? I think one of our friends has done it. What about the other persons may know? Fine. So you please calculate A. I will write the solution. You please confirm me. Yeah. Only plus cos x or minus cos x? integration sin x minus cos x, right? Okay. If so, I will write the final answer. Could you confirm me? I am writing the answer on doing the simplification. This is the final answer. So applying a into u plus b into v and doing y is equal to yc plus yp, that is the final answer. Now here, in doing variation of parameters, I just want to mention one interesting thing. I think the concept is clear to everyone. You just need a list of problems to practice more, isn't it? Do you have any doubts with regard to variation of parameters in solving the problem? Okay. So far we have done the problems with constant coefficients only. Here coefficient 1, which is a constant, coefficient minus 2, constant, coefficient 2, constant. So you have applied variation of parameters under constant coefficients. However, the same method is applicable for variable coefficients too. So the typical problem will be asked on variation of parameters. If the weightage is 15 to 20 marks, he will give the variable coefficients. So the module will be among the three categories. First one, he will mention u and v directly. So the only thing is you are going to calculate uv dash minus vu dash, evaluate the integrals ab, find yc and yp. That's it. And second module is you are going to determine uv by using the 6 formulae. The thing is you are going to apply p plus qx, 1 plus p plus q, one after the other, and you have to evaluate the two things u and v on your own, because for such kind of problems two conditions will automatically get satisfied, so that you know the values of uv and you can apply. For finding yp, we are applying variation of parameters. And the third module is the formulae so far discussed are not useful. It means you can find u, v, it is not possible as per the 6 formulae concerned. So what happens? To determine v, I have given the procedure y is equal to uv, right? You are applying this methodology in which you take RHS 0. So what happens? The arbitrary constant part, I mean, whenever RHS is there, in this solution, yp will be included automatically. If you take RHS is 0, and if you apply the same method y is equal to uv, you get only complementary function cf. So, for finding yp, we apply the same thing, a into u plus b into v, and the remaining thing follows. Okay? Are you getting the logic? Yes or no? Right. I will give you examples too, as a list of problems to you. Because I am going to put a daily test or practice test for you, which give you the total thing. The typical thing under variation of parameters is this. Having u and v in the problem itself, you have determined uv by using the 6 formulae. One thing is given by the formula and the v will be given by applying uv method in which RHS is 0. No, just let me write the thing. I have written this formula, right? . Accepted? I am saying that you apply the same formula to determine V, but here you take 0. If you take 0, it is a homogeneous equation, right? Obviously, we will get two constants. C1, C2 will come automatically by using y is equal to uv. There is no doubt at all. So, which are nothing but the complementary function solution. So, for finding yp, the usual procedure is as usual, a into u plus b into v. Because you know what is u, what is v. Accepted now. Right. So, that is the maximum typicality in the problem. Whenever such kind of thing is there, you can definitely expect a 20 marks question for this kind of thing. It takes nearly 15 minutes for you to solve the problem. The minimum weightage should be 20 marks. So on Monday's session, I want to give a daily test on you on the methods which I have discussed. And I will discuss about various of parameters by taking some of the variable coefficients and Cauchy-Euler equation. Provided I want to take one more value also, which completes ODE. If you have any doubts with regard to the previous method, I just want to take one doubt clarifying session on Tuesday. Otherwise, we can wind up on Monday itself, right? So that is my module. And randomly, you can post your doubts in Telegram with regard to ODE previous year questions. We can cross-check one another. I think you are doing those previous year questions after prelims. I hope so. If anyone has done enough preparation for prelims, so I request you that please solve the questions of ODE with regard to this part, right from 2017 to previous things, and post one after the other. I just want to say, can you bifurcate those questions on your own? Each year, one person can take part of that. 2017, one person, 2016, one person, like that. So you daily solve one question and post in Telegram with solution. Others will note that, so that the entire ODE will be solved by you. Is it accepted? Just one question per day, one person. Okay. You are solving about you are asking about daily test or the total thing, the booklet. I hope that the booklet is already posted by Hitesh in Telegram group itself, right from 2016 onwards. So you discuss among each person will take, okay, daily test I will post it tomorrow, sure. I will post it tomorrow, sure. Or at least in the early hours of Monday itself. So thanks for all, that's all for the day. I say that each year should be subdivided to one person, 2016 one person, 2015 one person, like that. In that year only you post one solution per day, that's it. So which won't affect your prelims preparation, and simultaneously we are concentrating on math optional too. Yeah, we can do the same thing for all topics too. So within 1 month, the total thing will be solved by all students. So you discuss among yourself. The typical questions we will discuss and post as solutions separately at the end. Because some topics are covered by students, some of them have not covered them. Thank you very much. Yeah, I agree. I hope everyone will get qualified in that.